Hi, my name is Abdel, and I'm a fourth year mechanical engineering student at RET. In the fall of 2019, I had the opportunity to study abroad at RET Dubai, and I took this course, Strength of Materials 2, where I had the opportunity to work on this awesome project called combined loading. And in the next slide, we have the problem statement, which is about a steel shaft being subjected to three different forces in the z-axis, in the x-axis, as well as the y direction. And the ultimate goal of the project was to determine the shear stress and the normal stress at point H and point K. And what I had to do was basically to hand calculate the stresses at those specific points, and then derive the values using a computer-aided device, which in this case was NX Siemens. So in this slide, we just have the steps that I took to complete the project using my hands. We have the area, the polar moment of inertia, and the first moment of area. So these are the specific steps that I took. I'm not really going to go into the detail because you can already see the calculations for yourself. And the next slide, we have the shear stress. And the next one, we have it at point H. So this is normal stress in X direction at point H, and this is the shear stress on the plane XZ at point H. And this was the same analysis, but at point K. And right after I finished calculating these values with my own hands, I used CAD, which is a computer-aided device, NX Siemens, used in this project. And this is basically the same thing that was on the original problem. So I had created this steel shaft in NX Siemens, and I applied the loads just like stated in the problem, in the Z direction, X direction, as well as Y direction. And when I ran the simulation, I found this was the final result of the simulations. And this is specifically the stress analysis using von Mises theorem on the simulations. And the colors indicate the values of the stresses at different points. And in this case, we're going to be analyzing the stresses of point H, which is on top, and on the side, point K. And right here, we have the values of the stresses, again, at point H and K. And then this one was using a different method. And after using a different method to find the stresses, we find that the values are approximately the same if you round them off. Again, different method, but at this point, we're just calculating the minimum principal stress. And this was for the shear stress at point H, which was 2,000 psi. And again, how did I know that? Well, it was approximated. Right here you can see the color was green, yellowish. If you look on this side, it's about 2,000 psi approximately. Did the same thing for shear stress at point K, and the value is right here, negative 2,200 psi. And right here, I created a comparison table to compare the differences between the hand calculations and the simulated values. So the simulated values is also called the finite element analysis, or FEA. And these are the values that I found. So if you look at them, we basically see that the values are almost the same, but sometimes there might be a little bit of discrepancy. But this is expected because when I ran the simulations, I couldn't be as accurate as I was using my own hands, because it's a little bit hard to tell. It's a little bit hard to tell the values of the stresses when you're using a simulation, because there's no tool to indicate the specific point that I'm trying to analyze. But anyways, it was a good project because I was able to determine the differences between the hand calculations using von Mises theories, as well as minimum and maximum principal stresses theories, and then replicating the same thing on NX Siemens, which is the CAD program tool. And this is usually what engineers use when they're asked to design some of the things, like such as beams or steel shaft. They can use it to determine the maximum shear stress and the normal stresses at specific points. And the ultimate goal of that is to determine the maximum weight that can be supported by the beam or by the shaft. And this is the end of the project.